Okay, so we're going to go over characteristics of a function. They've given us a chart here. Okay? So this chart consists of our x values and our y values. Now normally, we're on a Cartesian plane, so when we make our graph, our x and our y are written like this, and our x is our independent variable. Okay? Just need to know that by definition. So x would be our independent variable, y would be our dependent variable. In other words, it depends on what x is in order to figure out what y is going to represent. In your textbook, they've represented these charts in many different ways. One of the ways we're going to need to get used to representing a chart is something called domain, and another thing called range. Okay? Domain is going to work with your x-axis, or all of your x points. And your range is going to deal with the y-axis, or all of the y points. Okay? So very important to remember this. Domain, x. There you go, domain, x. And is this going to change? I guess not. It's unfortunate. I'll do it that way. And range deals with our y. Okay? Now, when we write domain and range, we usually write it in a style called our set notation. Okay?
I don't know. Volleyball here?
And set notation kind of looks like this. You would write down, or you can write down domain, and I'm going to write domain beside it. It's not necessary to always write it beside, but it'll help us make sense of what we're doing to start. So our domain is set up like this.
Oh, yeah.
X, and we usually write as all real numbers. Now in this case, because this isn't a continuous, we only have so many x values. Our x values are 1, 4, 5, 7, and 9. Okay? So I don't need to write x, and we'll talk about continuous functions after. But my domain is essentially just 1, 4, 5, 7, and 9. And these funny looking brackets are essentially what our set notation is. Okay, we've set it up like that. That is our domain, just the numbers that are under our x values. Range is the exact same idea. We just put the y values in. Now, let's go through our y values. We have 3, 6. I have 3 again. I do need to repeat it. Okay? So if that number has already showed up once, I don't write 3, 6, 3 again. We just write 3, 6. Skip over to 3 since it's already been written. 8. And normally we do this in order, so I'm going to squeeze 1 back in the front there. Okay? So I have 1, 3, 6, and 8. You try to write them in from lowest to greatest values when we do this. Okay? So we have our domain and our range for these numbers. So this is one, and of course there's going to be one very important way that we're going to represent these things. Okay? So I really want you guys to get used to your set notation, which looks like this. Because throughout the rest of this book, we're going to be talking about set notation and representing domain and range that way. Okay? We're going to show you a couple other ways to represent these things, and your textbook's going to use it. They'll focus mostly in Chapter 1, and then from there on we won't see too much of it after. They also represent domain and range with 2 ellipses. Okay? And very similar to what's written above. Yeah, Nick?
Why is there no consistency with x and y? No numbers.
Just random right now. We don't actually have a pattern going on with the x and y. Okay? They're just giving us arbitrary numbers. So, our x values, we're going to write them in again. Our x values are 1, 4, 5, 7, and 9. And again, our y values, this is another way to represent it, okay, is our 1, 3, 6, and 8. Now, the only difference here, we've written them in these types of ovals, you could say. I'm going to write, and this one helps us out, relate back to our other chart, which is corresponding to which. And what I mean by that is, remember, our 1 had a y value of 3. These are known as coordinates, right, when we write them in a chart like this. So our first coordinate is 1 and 3. So our very first thing we're going to do is we're going to draw a line. Actually, I have lines on here. from 1 to 3. Okay? That's our first set. Our next one is from the x value 4 to 6. So we go from 4 to 6. Our next one is from 5 to 3. Okay? So it can be common for two numbers to point to one y value. Okay? That happens. We just represent it by making sure we point to the same number. Our next one is 7 to 8. And finally 9 to 1. Now this one can be quite a bit more confusing, if you notice, okay? But we can represent it this style. It's just another way of setting up our domain range. But remember, our set notation, which is the very important one, this is our set notation, which I really need you guys to remember throughout the rest of this chapter. Okay? And finally, another way we can represent it, which we've been doing throughout the years, is with a graph. We're going to just plot these points on a graph. So we're going to quickly bring up a graph here. Go. Write it down a little. I'm going to write our coordinates onto this graph. Okay. So our very first coordinate is 1 and 3. So I go across 1 and up 3. Here's one of the points. Another point is 4 and 6. So I go over 4, up 6. Another point is 5 and 3. Right beside 5 and 3. 7 and 8. 7 and 8, roughly there. And then again 9 and 1. 9 and 1. Okay, we're going to zoom in a little on that now.
Nice.
So we've plotted all of our points. Our coordinates are down there. Essentially, this is just another way to represent those x and y values. We've put them on a graph, which you guys are very used to doing. So the two new styles we talked about are set notation. I don't even know if they have a name for the other one. Just representing with two ovals or ellipses, we'll call it. And graphing. Okay? So we've put all of these coordinates up. These are three different ways to represent it. We're going to get into whether a function is a function or not in a second. But I just want to make sure you guys understand this. So they gave us the chart, but this is also a way to represent it. So we have a chart as our first style. Okay. Our second style is set notation, which is like this. Our third style is with our ellipses. And our fourth style is a graph. Okay. Now, in order to tell if something is a function, it needs to pass something called the vertical line test. Okay. Now, the vertical line test works with a graph. So plotting the points becomes very important. And a vertical line test means if I draw a vertical line through each of the points, yeah, I'll try my best. Zoom in a little there. That wasn't quite on. Okay, so when I draw a vertical line through that, how many points do I hit? In order for it to be a function, I can only hit 1 point every time I draw a vertical line. I can draw an infinite amount of lines. So I can draw one here, one here, one here, one here, one here. Every time I draw a vertical line, how many points did I hit? Just 1. Okay? That means this is a function. Okay? Because I only hit 1. Had there been maybe a point down here, and even though in these ones we only hit it once, but in this one we hit it twice, this would not be a function. So in order to be a function, we need to pass the vertical line test. So it's easiest in graph form to tell if something's a function because we just draw an imaginary line through it. It becomes a little more difficult when looking at it our other ways, and we'll zoom out again. This way here becomes a little more difficult. Okay? And what you'll find is, for something to not be a function when we're in our ellipse version or our oval version, is if our x value, so one x value, has two y values, or in other words, two arrows leaving it. So in this one, if you notice, there's always one arrow from every x value. Okay? Only one arrow. So that means we do have a function. Okay? But had I had, let's say for the number 1 was a coordinate of 1 and 3 and 1 and 1, this would not be a function. And if you refer back to the graph, The reason for that would be, well, we'd have a point at 1 and 3 and 1 and 1. And if I drew a vertical line, I'd be crossing 2 points. Okay? So that's how we know if something's not a function in our oval version. Set notation becomes much harder. In fact, we can't tell from set notation. Okay? And they'll give us set notation. They need to give us more information in order to tell if something is a function. Because remember, we did have at least 2, 3 values. Okay? We don't know how these numbers relate to each other. So we need to have at least another representation where it's a chart, an oval, or a graph. Set notation just makes everything simple from us. We're not actually able to tell if it's a function from it yet. And finally, from a chart, we would just look for the same x value with 2 different y values. Well, in this case, we don't have that. We have all different x values. But let's say we had one more coordinate again that said maybe 1 and 1. Well, in that case, I'd have 2 x values with different y values. And if we were to plot that on a graph, again, our vertical line would touch 2 points. Okay? So in this case, we do have a function. It is a function. In our other example where I was showing you, if it doesn't pass the vertical line test, that means this is not a function.